Hey all, good morning, good afternoon, good evening, based on which part of world you are watching this series. Welcome everyone for today's talk, which is on streamlining infrastructure deployment using the two fancy tools, Packer and Terraform. Who am I? Why I'm speaking this? Myself, Vasan. I'm senior cloud and DevOps engineer as part of an organization Mindra, and you see the LinkedIn link, which is a Kittivasan-Kannan, which you can follow. And for any follow-up questions, you can leave a ping over there. I'm also hold 6 Cross AWS certified, and I also hold fancy Terraform associate certified person. In my part time, I do run 2 YouTube channels, one EVDI and the another Tech Page. So both is around AWS, DevOps, Terraform, and fancy technical topics. One in the Indian regional language Tamil, the tech page, and the other one it's in global English. So if you haven't checked it out, I would highly recommend to check it out and do follow. So today's agenda. So these are the whatever you see in the screen. So we'll talk about the infrastructure. What is infrastructure? How we can automate it using infrastructure code. So when you say code, it's not a real-time programming language. It's going to be like a couple of syntax which HashiCorp offers. And how can we use Packer to configure our infrastructure, and also like how we can streamline it using GitHub Actions and few best practices that to be considered when we streamline this. So that's going to be part of today's agenda. So without wasting time, let's deep dive into the session. I also have a couple of demos planned in middle of the session, and also I'll be sharing the GitHub repo for the entire demo code which we do using Terraform, Packer, and the GitHub pipeline. So you can still go back and try to get your hands dirty post session. Since I come from the AWS background, so I have listed a few services which represents infrastructure. In other cloud, it would be more or similar. So you have S3, for example, in AWS for storage service. You have cloud storage in GCP, likewise the other in the Azure. So we have EC2 instance, we have Lambda, you have EKS and SQSSNS and more. So these things we generally call it as infrastructure, right? So we procure a cloud infrastructure to host our application. We do fancy serverless, server-based, and more. So out of all these infrastructure, so generally we can create infrastructure using either infrastructure code like Terraform or the cloud native providers like CloudFormation and more. But what today we'll be focusing on the service is EC2. Okay, so so this one we spoke just now. So the infrastructure code. So why we want to do as infrastructure code, as many would have spoken in today's session about Terraform, it's to track your change. You can easily replicate in multi-cloud, and you can automate more on that. So yeah, so first we'll start with Terraform. Obviously, Terraform is going to support multi-cloud. You can write code, and then you can use multiple cloud management into a single repository and play with it. It's not just limited to cloud. It also offers you like other providers, like you have Cloudflare, you have Azure Active Directory, and Kubernetes, like few to mention, which is not cloud. So Terraform is not just meant for cloud, but you can automate even, you can write your own custom providers if you're developing a product for Terraform using a Go language. So coming back to the infrastructure, as I was mentioning about infrastructure, like it's not just about creation of infrastructure. The peculiar service which we today will take as use case is the EC2 instance, where we just not create infrastructure, but we also configure it. So when we configure, I say is that we would need certain, let's say if you're launching an web server, Apache server, then we might need to pre-install the Apache server when we boot, so that the server can be up and running. Or we might need to create some log file configurations, or we might be having a custom requirement for our own application use case, which we want to keep it ready. So those things we call it as configure. And today we'll see how we can use Packer in terms of to like pre-configure and how we can bake it, how we can use it in the Terraform world, and how we can pipeline it. So that's going to be the entire session. So for creation, we'll be using the Terraform. And if you want to create a EC2 instance, the web server or server in the AWS world, you need to use AWS underscore instance resource type, and bare minimum they would expect this two specific field to spin up your instance. And obviously, like, you would be adding the provider configuration to say like what provider, which region your EC2 instance would be created. On scenarios of spinning up an Apache instance, let's say Apache server, then you would be also passing the user data to it to get this server up and running. Okay, so let's see how we would be writing a Terraform code and how we would be running it, and how we can spin up the EC2 instance quickly. So it's a demo time. Yeah. So what I have a folder called infrastructure for this specific purpose, where I have written a main.tf, which I showed just a couple of seconds back. So where we have a resource, the resource type is AWS instance, and this can be any naming. It's a unique identifier. You can keep it Watson server, web server, Apache server, or any. And then we will need to pass the AMI value, the AMI ID, which is going to be the base OS, right? From where the instance will be like using it. Is that Ubuntu? Is that a custom AMI with custom packages? So based on that, we'll be choosing it. And instance type, like based on our use case, based on our CPU need, and the T2.micro is the minimum we can go for it. And the security group, it's to allow like what ports we allow, from which source IPs we allow. For demo purpose, I created a security group already, which is allowing the port 80 from overall traffic. And I'm using the user data for now, so that we would be installing the Apache server, and we'll be writing an HTML file. And as an output, once the server is created, we'll be printing out the public IP, so that we can go to the browser, hit it, and see are we getting the message, hello Apache is running or not. And obviously, so I added the provider configuration. So since for demo, like, I kept everything in a single file, main.tf, but for ECDWT, we can split into like multiple files, like provider.tf and output.tf, and if you're using any data block, data.tf, and more on. So today's primary focus is to like spin up an EC2 instance with an AMI and see how quickly we can do it, right? So I already configured the credentials. So if it's the access key, I already set it in my local machine. So all I'm going to do is the cd infra, and then here we have our the main.tf file, as you could see. And first thing you do is to initialize the Terraform, so that all the providers, so provider is the integration between the API and our code, to see like what resource will be created, and what we are asking it to create, and what type of resource and credentials, right? So those things, to enable the communication between our code to our account or to the service, we use provider, and we are initializing it. And the next one is to see what our change is going to do. Are we going to destroy the existing resource, or are we going to create a new one? What is going to happen, right? So we'll be getting those details by running Terraform plan. So you could see that we are creating an EC2 instance with the AMI, and details are like, what are the details will be like applied. And to make our life easy, like rather going to the console and looking for like what is the public IP of the server, I'm printing it out. So once the server is created, we'll be getting the public IP right instance in the terminal, and then we can go and hit the browser to see whether the server service is up and running or not, right? So let's apply the change. So if you do apply, it's asking for the confirmation. Let's give S. And so once I give S, it's going to call the API to see like, hey, I'm going to create a EC2 instance of this, and this is the AMI I'm looking for it, and get it on created. And if you see, the server instance created, and we also got the public IP of the server. So if I go to the browser, and if I hit the public IP, so by default it's going to HTTP, and we see the output, which is hello, the Apache is running, right? So we can also cross check in the console. You'll be able to see an EC2 instances spinning up, running, and the same public IP exists over that. So it's very bare minimum in terms of creating an EC2 instance, using user data, where to launch the server, and then we just hosted a centralized index.html file, and then we also allowed the port, right? So if told that we already created a port which is to allow port 80, and we are allowing the source 00. So to delete the instance, again, it's straightforward, right? So we just do Terraform destroy, then it's going to delete the server or delete the instance for us. So let's give yes, and boom, so it will get destroyed. So that's the more power of infra's code, where we create once we have the base code ready, right, and the template or instance ready, then we can create it within fraction of seconds and destroy it within fraction of seconds. So this can be like helpful in terms of cost saving. Like if you have a non-prod instance, you might need to shut it down like Friday evening 3 o'clock and then bringing it up Monday morning 9 o'clock. Then you can schedule it as a job, so that without any manual interruption, you can still save the server runtime building part, right? So let's wait for it to destroy and let it destroy in parallel. So let's move on to our demo part, right? So we have seen how we can create an EC2 instance, how we can use user data to launch the server itself, and then we also evaluated is the server is up and running or not, both by hitting the public IP, and also we checked ourselves in the console, and also we have seen how quick is to destroy the server, right? So if you see the user data, so I went a bit quick in terms of like you would have hardly seen like a couple of lines. So if you see, like, we ensure when the server is spinning up, we are updating the package, and then we are installing the Apache. That's what the systemctl start HTTP does, and then we also creating a file, the index.html file, which to be get indexed whenever the default slash path is being getting called, right? So in real world, you don't need to, you're not going to limit within this. You might be having some custom package like Java to be installed or Python to be installed, or you might be having custom application packages, which can take a lot of time, right? So in our case, it's quick, but what if it's taking like a lot of time, or you want to standardize, say I need to everyone to use a specific version of a Java or a specific certain standard to be maintained across all the organization, then that's where the key centralized configuration pattern comes in, and that's where we move from here. In this case, like let's say if you want to launch like 10 different instances, these are like repeated part where you are going to install, so it's going to take a bit of time, and then you're going to the starting of the one which should be do at the server level. So we can move the repeated process where the installation, where we think the time going to happen, or it will be helpful if it's like pre-installed. So those things can be achieved using Packer. So Packer is a tool which helps us to create an standardized AMI. So in industry, many calls it in different name. The standardized AMI, a few call it as golden AMI, a few call it as pre-baked AMI. But ideally, what they directly translates is you create an AMI, which is Amazon Machine Image, or the similar, the pre-baked OS, from where you can spin up your instance, where you can standardize the image, so that the standard is being set, like what packages should be come and what's allowed, so that no new tooling gets into your server without your knowledge, and by which you ensure your security is being enforced, and so and so. So how we can do it with Packer? So in Terraform, it was quite easy. Like we see the resource block, we see the provider block, we see the output block, and we ran couple of commands, we spin it up, and we ran destroy to destroy it. So Packer also, it's quite similar. So we have the Packer required plugins, which is equivalent of providers to see like where it's going to communicate. Then you have the source block, of which like which AMI should be taking as a base image, and from where you are going to run your custom command. So whatever the pre-installation command is going to be imagined as a one layer, and on what OS these commands should get run or executed. So in this case, you are using filters to say like, okay, this is the base image I need to get filtered, whichever is following this category, and which region I'm running it. So in this case, it's been mentioned US West 2. You can use EU West 1 based on your use case. And then the major thing is the owners. So owners is the AWS account, not your AWS account, but each AMI from where the base image you are going to use. So that base image where it lies, that specific account you need to be providing here. Yeah, and then the other factors are like more self-explanatory, like this AMI is going to use in what type of instance, what region it should be created, and what is the AMI name you are going to use for this. So everything is like straightforward, but what you need to keep in mind is that the owner's account is the actual base image owner's account, not the account where you're going to execute a command. And then the build block. So the build block is where you would be mentioning in terms of what are the commands or what are the packages that should be get executed as a default within your base image. So what goes in inline? So if you recall, few minutes back, we talked about Terraform and user data. The M block, the echo block are like more repeated structure. So if you want to pre-bake it as an AMI, so those blocks would go into the inline piece, and then we will be building up the AMI out of it. Okay, let's see a quick demo of how it would look like in real world when it comes to Packer building an AMI part. Right, so back to the code. So I create a file called Packer, and the Packer follows the file extension .pkr.hcl. And I missed to mention, like, the Terraform would follow the extension .tf, and the Packer is we use ami.pkr.hcl. And same as, so you can use variable to refer, set the values, and then you will be referring those variables using var dot the variable name, so that the values get fetched from there. So Packer required building. So based on what API you're going to use. So in our case, we're going to use AWS. So I'm using the plugin for the Amazon part, and everything is available as a document in the Packer website. So based on what cloud provider you're going to use, you will be using that. And so this is also, again, the documentation is readily available from the Packer website, where we're using the source Amazon EBS, which is we're creating an AMI for Amazon cloud, and this can be anything. It's just for our reference. So you can name it as Ubuntu, you can name it as web server as part of it. And so I've declared the AMI name as Wasn't Packer demo. Maybe I'll keep it as one-, because that should be already one I created. So just to differentiate, I'll create it like demo-1. And the build is where we inline commands, like what are the commands that should get executed. So about this one, I'll come back in the upcoming slides, but it does pretty much the same, but you would see something varying than which we did in the user data. I'll talk about that in the upcoming few minutes, like why we ended up in this state of inline, why not just doing the same as we did in the user data aspect. And so that's more about it in terms of the Packer itself. So to do the Packer, so you go for the folder, Packer. So you can use Packer initializing factor, so that all the plugins, anything you have in place, that gets initialized, and then you can validate the Packer using Packer validate the file name, so that it's checks if everything is fine in terms of format, in terms of values that you would expect. And then to run it, so you would say Packer build and then the file name. So to build, it takes a couple of minutes, say in my case it took something around like 10 to 12 minutes in generic. So we'll also go to the console and see the AMI page. So you'll be seeing somewhere here there is already one exist which I uh, tried creating for testing purpose. So instead of demo, it should be like demo-1. A new AMI should get created post successful run of this job or this run. So let's wait for it. All right, so the base image is created, and the pipeline says like it's waiting for AMI to become ready. So if I refresh the console, we could see that the new AMI which we created has been created, which is demo-1, and it's still in the pending stage, and it would hardly take another 5 more minutes to bring it be available. So you might ask like, hey, when we run Terraform and user data, it was like quick, fast, but then using this AMI, it looks like time consuming, but it's one-time activity. And if you think in terms of bulk server where you want to standardize a centralized AMI, this not only help you in terms of the time consumption plus also in terms of standardizing the AMI. So both in terms of security and time consumption, this the pre-baked AMI would come handy. Okay, so in parallel, let's let it go. In parallel, I will show you like how we can streamline this. So we have seen two different things: the Terraform for running the resource creation of server, and then the Packer for pre-building the AMI. And to streamline this, we can use GitHub Actions. So if you see, I have created a repo infra Streamline. Post this session, I will make it public so that you guys can go and refer the code if you're interested. And I'm using three the SS keys for the GitHub Actions to run, and I have placed the workflow in the .github workflows path. Let's quickly go through like what I have written, and then we'll take it from there. So I have said like on main, so whenever I'm publishing any new changes to the main branch, it's going to trigger the GitHub action. You can also play with it in terms of pull request to main or any future branch with a keyword. Like GitHub action supports a lot of multiple approach to trigger it. And then I'm using the native option within the GitHub actions to clone the repository to the running server so that it knows what code file we have in place. And I'm setting out my AWS credentials to the local machine. So if you are using GitHub Actions using your self-hosted runner, and if that runner is from AWS instance, then you can use the IAM role itself. You don't need to set this credentials part. Since for demo, I'm using GitHub Actions personal account, so I'm using this temporary credentials for the demo. But in real world, you would be using IAM role so that you don't need to worry about these credentials, and that IAM role would be assuming some other like standard IAM role part of it. And then I'm installing the Packer here, and again same as you see in the previous demo, like I'm running the init image and I'm validating the package. And ideally this one would be doing a building process. Just for demo purpose I commented it because it takes like 12 minutes of time to build it. And then we can also run the Terraform part by initializing the Terraform, validate it, and then apply it in the on the fly. So let's see how it would look like in real world. And what I'm going to do is I'm going to comment the user data. No, I'll keep the user data, but I will remove these files or EOF. So for that, and I'm moving this line and this one. Okay, so let's check it now. Now it should not complain, and it should go through in terms of initialize phase. And let's see. So it's configuring the credentials, Packer is done, initialization is done. Yeah, so the Terraform init has been successful. Then it will be validating our Terraform code. The validation is done, and you see it's doing the Terraform plan, and the instance is getting created. So we are pipelined the process in terms of baking the AMI, and so we have also got the public IP of the server. So if I hit it, you see we created the server using the pre-baked AMI, and the server is up and running. And if you see in the console as well, this is an AMI, and the instance, there should be one instance picked up. Yeah, you see it's running, which is the instance which we created using the pipeline part. So yeah, we have seen like how we can do it in the pipeline part. So here for demo purpose, I kept both in the same repository in terms of building the AMI and creating the resource. But in real world, you would be using like building the Packer using a centralized repository, and then using Terraform data block. You'll be using the AMI ID reference here instead of directly hard coding it. You would be using data block to refer it, so that using filters you can get the latest AMI value and streamline it. Yeah, so this is generally how we can streamline using GitHub Actions and Terraform to create a resource, and Packer to create the pre-baked AMI part. So few best practices to keep in mind. So always it's good to keep the AMI creation process in a separate repo, not merge it with where you actually create the server, unless you have a requirement that an AMI should be created and then server should be created, maybe test instance or something like that. Because the ideal reason of AMI is to use that wider audience, right? That's where the golden AMI or pre-baked AMI comes in. And if you want to make your instance wait for each time of AMI creation and then do it, it can be a bit lengthy process. So that you can consider in mind in terms of doing it. And you can try to containerize it, the entire process. If you recall, I was mentioning about why our user data and why our this specific thing is like a bit quite different, right? So if you see in the code, we used somewhat different in terms of the sudo stdi app part and stuff. It's because that we were using here the base image as Ubuntu, and the Packer which we ran, it was running it locally in my system, which is Mac OS. So when I was executing it, and how the way like how the local machine was handling this was completely different. So when I tried locally, I was using the same command of how we did it in the user data, and it works fine. But then when we wanted to use the Ubuntu latest one as a base image in the GitHub action and run it, there were like certain hiccups being came through. So to regularize it, we can try to containerize it so that the command remains constant. Either you test it locally, you run it anywhere else to maintain the consistency aspect, like how you deploy it, right? So rather deploying it using directly local machine, or if you're comfort with doing it in this way, that's different use case. But best practice is to avoid wasting time here and there. We can try to containerize the process aspect. Whatever the AMI you create or whatever the instance you create, always ensure to tag the resources so that you know if you want to filter it, if any AMI is being used, then if you automatically create the tag as part of the resource, then it will be easy to backtrack by running the API is filtering out based on the tag value and see any outdated AMI has been there in place or not, or like how much cost you could save or around that aspect. Also, always follow don't repeat yourself concept. If you are using Terraform, try to use that module, make it as a module so that you don't write the same code. Also, you try to introduce variables as much you could so that the code remains dynamic and you can repurpose it for some other use case. And more on. So that's more I want to talk and share as part of today's session, like how you can create an infrastructure, in our case EC2, and how we can use Packer to create a golden image, and then how we can streamline the flow of creating the AMI, using it in our flow, and how we can work on that part, right? So that's part of today's session. So I will make this code public post this session, and you can scan or you can visit GitHub ebdi infra streamline repository to look at it. And if you have any specific questions, you can do connect with me over LinkedIn. Feel free to ask for any questions. Happy to assist or happy to answer if I'm aware. If not, I can still go and try to fetch the answer if I'm not aware about it. It's all about getting to know what we unknow. So any minor, major stuff, do ask it. If you're watching the stream live, I'll be around in the chat, so feel free to ask. Thank you. So thanks for staying till end of the session. Really appreciate your patience. If you have any feedback or anything, do approach me over LinkedIn. I'll be around. Thanks.